This is chapter 3, section 3, and this deals with the equation y equals mx. Now, y is our y coordinate, okay, and x is our x coordinate, and the m we learned yesterday is, or the day before, is slope, right? M stands for slope. Do you remember that? Okay. And then we have this thing called direct variation, and that's just when two ratios are proportional. The ratio of y to x is the constant. Remember, y over x. Okay, so that's our slope and our constant. Those are the same things. That doesn't change. Okay? And we have the formula here where m is the slope, and that stands for rise over run, which we talked about already. So the m is always in front of the x. That does not change. The m is always in front of the x, which means our slope, our value for slope, is always going to be in front of the x in this equation. So if I give you an example and I said, here's an equation, y equals 2x. What's the slope of that equation? Y equals 2x.
2.
2. Wow, that wasn't very tricky. What if I said y equals x? What is the slope of that equation?
1.
1. Good. Not x. It's 1 because there's that imaginary 1 in front, right? Okay. What if I said y equals negative x?
Negative 1.
Negative 1. You guys are quick today. All right. So what we're going to do, see, short notes, is on page 194. We are going to do problems 1 through 5 together, okay? I don't want you writing this all in your notebook right now because it'll take some time. But you can write it in your workbook, and later on if you want to transfer any of it to your notebook, that's fine with me, okay? Or some people like to take a picture of their workbook, and then they print it out and they glue it in their notebook. Imagine that, right? So it's less work. So go to page 194, and we're going to do these together.
Where are you doing to do some type of really mean prank on us?
Nope.
Are you sure?
Yep.
Are you lying?
Nope. All right, 194.
Recording.
Shh, it's still recording, you guys. Yep. Okay. So you see, as you turn to 194, you see there's a lot of words. Can you guys see them? I'm going to put this under the doc cam. Okay? So everyone can see it, just in case you don't have your book or something. I think everyone does, but it's under the doc cam. So if you don't have your book, you'll just write this on in your notebook or on a piece of paper. But let's do these together. So it says that we have a color printer, and it can print 36 pages in 3 minutes and 108 pages in 9 minutes. If the number of pages varies directly with the time, at what rate is the color printer printing? Okay? So we have certain amount of pages over time. We have a y over x problem. And you're probably starting to see what you might do to set it up. But just in case you're not, what's 36 divided by 3? And what's 108 divided by 9? Aha. So we set this up like this, 36 pages over 9 minutes, and that equals 12. And we also set this up as 108 over 9, and that is also 12. So when it says if the number varies directly, that's what it means. It means we have... Oh, I'm sorry, guys. It means we have the same ratio. I was looking at the 9 right there. So we have the same ratio. You see that? So if it says it varies directly, we have the same ratio. And that would be 12 what? 12 pages per minute. Good. Okay. Number 2. A new compact car can travel 288 miles on 9 gallons of gas. The distance driven in miles, y, so you can underline that, varies directly with the number of gallons of gas, x. This situation can be represented by the equation y equals 32x. Where do you think they got the 32 from? Anyone have any ideas?
How many miles they drive?
Okay, so he's saying that it's miles. So if we go to miles and then gas, it must have some sort of rate of 32 miles per gallon, right? Is that what you're all thinking? What are you thinking?
It's the slope.
It's the slope. What are you thinking?
It's 288 divided by 9.
Oh, okay. So let's see. It says he might be right. So let's graph the equation on this coordinate plane, okay? So graph the equation. So we have gas and we have distance, right? So let's look at this. It says 288 on 9, right? So we know that point, don't we? So let's go for distance. Let's go up to the 288, which will be like pretty close to the 280. And let's go over to the 9. So let's just go like right there. Now, I need 2 dots or 2 points to connect this line. Where could the other point be? Where could it be? Where? 0, 0, right. Because if you go 0 miles on 0 gas, that makes sense, doesn't it? You're just sitting there. So we can put another dot there. And then you can connect your dots. Straight line as you can. You know, mine's a little off. That's okay. Okay. So now I have some sort of graph here, right? And if I wanted to figure out my slope, I could do rise over run, or we could do like Bryce said, you could divide this 288 by 9, couldn't you? And when you divide 288 by 9, you get 32, and that's our slope. So if you wanted to, you could go rise is 288 over run 32, but that's the same thing you're doing. So we're going to write how many miles per gallon does the car get? So how many? What's our slope? 32. That's it. And I just put MPG. 32 miles per gallon. Okay, then part C, it says the distance Y, this is the distance, traveled by a hybrid car using X gallons of gas can be represented by Y equals 42X. Which car gets better gas mileage? What do you guys think? The first car or the hybrid?
Hybrid.
Well, of course the hybrid does, sillies. But look at the numbers. This one's 42, right? This one's 32, 32, 42. Obviously this one gets 42 mpg. So you would say hybrid, it gets 42 mpg. The other car, I guess we could say the compact car, gets 32 mpg. And you'd be done. Any questions on that? If you want to do the shorthand, you could put something like this. You could put 42 is bigger than 32. Right? Remember those? Those little inequalities? You could do that. Okay, number 3. Annie's current earnings are shown in the table. She was offered a new job that will pay $7.25 an hour. Assume that her earnings vary directly. Remember vary directly? What does that mean? It's a constant, right? It's going to be the same ratio. With the number of hours worked, which job pays more an hour? Okay, so this is like the other job, right? Annie's current earnings. And she's offered a new job that's $7.25 an hour. So we have our rate for the new job, but we need to find the rate for the old job, or her current job, I should say. Okay, so if we're assuming, look, this goes up by 1, right? These go up by 1. What's this one going up by? 650? It's in your book too. 650, looks like they're all 650, and it also told us that they vary directly, so that means they're the same. So 650 over 1 is going to be what? 650 an hour. So which job's going to pay more?
The new one.
Yeah, so we're going to write that the new job pays more. And then we'll use our shorthand and we'll say that 725 is greater than 650. Of course, right? Take the new job. All right. Any questions on that one? Pretty basic, right? Let's do number 4. This is a good one. The height of a widescreen television screen varies. That sounds weird. The height of a widescreen television screen varies directly with its width. Oh, so that means the height and the width must have a constant ratio, right? A television screen that is 60 centimeters wide and 33.75 centimeters high. Write and solve a direct variation equation to find the height of a television screen that is 90. So our first one, we have something like 60 over 33.75, right? And these are in centimeters. And the second one, and by the way, this is the width and this is the height. The second one, they're telling us that we have to find the height if we know the width. So this is the 90 over, and we can just call it x. That's the missing piece. So in the warm-up, when you did these problems like this, it was leading to this, right? Okay? So we can just figure out the ratio here, or we can cross multiply and divide, which I think is a little bit faster. So in the calculator, you would do 90 times the 33.75. And then you would divide by the 60. And that gives me 50.625, and this is centimeters. Okay? Oh, and it says we have to write an equation too. So you would do the y equals the, let's see, that's the width. So we actually need to divide this, don't we, to get the rate. So 60 divided by 33.75 equals that. Oops, let's do the other way. 33.75 divided by 60. So to write the equation, 625x. And I got that by doing this. I did 50.625 divided by 90, which is the reverse here. Okay? So that's that one. Now, the last one, 5. What is the relationship among the unit rate? Do you remember unit rate from Math 7? Any number over 1? Remember that? Slope and constant rate of change of a proportional linear relationship. What is the relationship? What is the relationship? What's something that all of these things have in common? What do you guys think? What do you think?
Wait, like words?
Yeah, well, just anything. What do you think? Unit rate, slope, constant rate. What do you think all of those have in common? What?
Fractions.
Yeah, they could be fractions. What else? They can all be shown on a graph. Good answers. What else?
They're all, you have to times and then divide.
Okay, a lot of them we multiply and divide. What about if I just said the slope and the constant? What do those have in common? The slope and the constant. What's that?
They show a rate of change.
Yeah, they show the rate of change. So are they all the same? Pretty much, they're all the same. So all you have to write here is that they all, yep, sorry. They all represent the same thing. Okay? They're all the same thing. So over here, you're supposed to rate yourself. So how well do you guys feel like you understand this concept here? It's the direct variation. How well do you think you understand? It's clear, somewhat clear, or not so clear. So you circle the one where you kind of feel you are right now. Just understanding this m being the slope and these ratios and all this stuff on this page. Circle what you think. Okay, raise your hand if you're clear. You circled clear. Raise your hand if you circled somewhat clear. And then raise your hand if you're not so clear. Not so clear. Okay, so most people are in the somewhat clear, which is pretty good because I just introduced it to you, right? So we should practice some more so that we get to the clear, sunshiny day, right? Okay, so the practice that you guys are going to do is it's on page 195. And you are going to do these alone so that you can see how you're doing. It's 195, 1 through 6. And then 197, 15 through 17. And I'll give you about 10 to 15 minutes, and I want you to try these. And then we'll go over them. I'll call on some people, we'll go over these. And then we'll move on. But that's it for the notes. See, it was short. Because remember on Tuesday, Wednesday, we did a lot of notes? And so I made up for it today. So do 195, 1 through 6, and 197, 15 through 17.